All right, let us now answer example 3. It says, Michael is looking to borrow $50,000 over a period of 3 years and wants to compare two different loan options to determine which is the better deal. Option 1. The interest rate is 4.8% per annum and is compounding annually. Option 2. The interest rate is 3.6% per annum, but it's compounding twice yearly. Find the value of each option after 3 years and state which is the better option for Michael. Okay, so as you can see here, if we look into our options, this one has a higher interest rate, but it's compounding less often. This has a lower interest rate, but it's compounding more often. The first thing we're going to do is we're going to figure out the R value of each of these. So this is going to be what? It's going to be 1 plus, then I need my little r value, which will be 4.8. Then I need to divide it by my n. In this case, if I'm compounding annually, it would just be 1. And then I divide that by 100. Over here, I'm going to go 1 plus my little r is 3.6. I'm compounding twice yearly, so that means my n is 2. And then I divide that by 100. When I put those into the calculator, what I'm going to end up with is 1.048. And this one's going to be 1.018. What I now need to do is figure out the value of each of these after 3 years. Let's figure out option 1 first. All right, option 1. Let's write out the recursion relation. It's going to be V of 0 is $50,000 because that's how much I'm taking out. V of n plus 1 is going to be equal to, remember, it was 1.048, and then you're timesing that by V of n. Now, here comes the important part. I'm going to do it in red. What I need to figure out is the end of 3 years. What is the balance in there? The end of 3 years. Well, this is important. If I'm compounding annually, what that means is that at the end of 3 years, it's just 3 iterations because you're compounding annually. So it's just 3 iterations. So it's going to be V3. To figure out what V3 is going to be, I'll come to my CAS calculator. I'll put in 50,000, 1, 2, 3. I then am going to times it by 1.048. So that means every year, I'm going to be earning 4.8% of the previous year's balance. 1, 2, 3. So I'm going to end up with 57,551.1296. Therefore, it's going to be 57,551.13. That's how much is going to be the loan. There it is. All right, let's now figure out what option 2 is going to be. So let's come over here now. We'll come over here and we're going to write down option 2. Again, it's going to be V of 0 is equal to $50,000. Then V of n plus 1 is going to be, now I need to remember what was it? It was 1.018. 1.018. And V of n. Now. This is where it becomes important, people. Pay attention, have your brains switched on. We again need to figure out what the end of 3 years is going to be. But remember, this one is compounding twice a year. If I'm compounding twice a year, how many iterations will 3 years be? Does that make sense what I'm saying? If I'm at the end of 3 years, if I'm compounding twice a year, how many iterations will 3 years be? It's going to end up being V6. Let's talk about why that's the case. Let's clear this. Clear. You're starting off with $50,000. I'm going to be timesing that by 1.018. And remember, this 1.018, that is occurring twice a year. Let's just take pause for a moment and make sure you're really understanding what I'm saying. Don't write this down because it will get a little bit messy. Let's draw it out. There's 1 year, there's 2 years, there's 3 years. And what we know is that twice a year twice a year. So I'll put, I'm going to be getting, so remember, what was it originally? It was, what's the date? 1.018. So that means it's going to be 1.8%. I'm going to be getting 1.8% there, then 1.8% there, 1.8% there, 1.8% there. And keep on going. 1.8% there, 1.8% there. I'm calculating the interest twice a year. Now, if you were to go 1.8 plus 1.8 across the year, it's going to be 3.6% each time, which makes sense because that was our interest rate, if you remember. The interest rate was 3.6% each year. But because it's compounding twice a year, that means you're calculating the interest twice a year at 1.8%. So this means this is V1, V2, V3, V4, V5, V6. 3 years gets you to 3 years gets you to V6 if you're compounding twice yearly. That's what's happening there. So it's really important that you have a good conceptual understanding of what's happening here. That is what's happening. So now when we come back here, I can feel that my computer's about to explode, getting a bit laggy. That's all right. This is what happens when you've been recording for a long time. Now, what I'm going to do is say, all right, what is V6 going to be? So I'm going to come to my trusty CAS. Now I've put in 50,000. I've times it by that. That's going to be 1, 2, 3, 4, 5, 6. It's going to be that. It's going to be 5, 5, 6, 4, 8. 0.911306. Therefore, I'm going to be paying $55,648.91. Now you have to figure out which is the better option. So which is the least amount of money here? I apologize for the lag. I'm going to have to give my computer a rest after this example. If I get to the end of the example, let's hope the computer holds in there. It's going to be $55,648.91. Which is the better option? Well, it's going to be option 2, because option 2 is less money. And remember, this is a loan. I want to be paying as little money as possible. So he should choose option 2 because it will cost less. So I'm just going to, and remember, you'd have to put this as a statement. Let me do it. All right. Wish me luck. Hopefully the computer holds out. He should, look at that lag. He should choose option 2 because it will cost less. We did it. Hopefully that makes sense as to why we did it in this manner. And yeah, hopefully this is all makes sense. A good little question. I now need to give my computer a little break before I go into the next part because, as you can see, he's getting a bit laggy. He's getting tired, as we all do from time to time.